So when I went to the next screen, I don't know. I don't know what my settings are on this. So I think it tried to just record this screen and then the next screen. And so I just had to stop and upload, then restart. And so here is example number 2. Okay. So we want to find the dot product of the two vectors. We've got vector v is -6, -5, and vector w is 10, -12. And again, when you're doing dot product, it's kind of like when we were adding and subtracting. You're basically just going to take your first numbers, right, and your second numbers. Those are the numbers that get to play with each other. Now, it's a little different. You're not just going to add them. You are indeed going to, for the dot product all right, so we're going to just call it A. So when we're doing dot product, you are going to do a -6 times a 10 plus a -5. Oh, I switched colors. There it is. -5 times a -12. Okay. So when you do that, you get a -60 plus a, oh my goodness, +60. And so your actual answer for the dot product, 0. Okay. Then if we go to part B, it's easiest to actually find the angle. In my mind, I guess it's the easiest to find the angle. I don't know that you would agree with me, but we tend to disagree a lot, so it's okay. To find that angle, remember you can go back to our formula, which I am trying to pull up on my MacBook right now. But you can do cosine of theta equals the dot product of our two vectors. And again, our book is very good about putting our vectors on top of, our vector symbols on top. Those formulas that I showed you did not have them, but it's okay. We know that we're dealing with vectors. So you do the dot product over the magnitude. Sorry, that's getting a little messy over there. You do the dot product over the magnitude of those two vectors. So you remember finding your the magnitude of a vector. Remember, if I wanted the magnitude of vector v, I would just take -6 quantity squared plus a -5 quantity squared, take that square root of it, right? We just think almost in terms of Pythagorean theorem. But here's the nice thing about this particular example, and I don't know if that will hold true in example 4 because I haven't worked it out yet. We just found the dot product, right? We just found it right here, this 0. So ultimately, when I'm trying to undo that, well, that's not going to let me do that. I'm trying to undo that little star, but I guess we'll just have to erase. When you do this, 0 over any number, I don't care what that number is, this is irrelevant to me at this point. I could find it. It would be what? The square root of 36 and 25 is 61. Square root of 100 and 144 is 244. So you could find them. It's not really all that important. So the cosine of theta has to equal 0, right? And so when we do this, we're going to do the whole inverse cosine thing, right? When we have the cosine of the angle, well then that just means that theta is going to be, and you guys can rock the degrees if you would like, because ultimately you're just going to go to your calculator. Because this happened to be nice, 0, and we could use our unit circle if we wanted to, but you won't always have that option. Okay? So let me shrink down. Ooh, goodness. Sorry, I didn't realize it was shrinking down that much. I just want to stay on the same screen. You're young. You should have good eyesight. It'll be all right. You can see it. So let's go and do the projection then. We'll go ahead and do the projection now. And here we go. So if will label it C. All right, we're going to do the projection of W onto V. Okay, so here we go. When you do this, A, you want to have a better stylus so that it's not so hard to write on your iPad. B, you're doing this on your paper, so it's not a big deal. Make sure you have your formulas with you guys, okay? I have not decided what formulas I'm giving you for your final, so, don't ask. Durf, I'm talking to you. All right, so this is just taking more time for me to put those there. So here's the nice thing about this. When you're doing this, I'll write it in a little nicer now. I'm not going to put my vector stuff on top of it. Oh, no, no, eraser. Okay. Again, nice thing is we found the projection, and that projection was 0. Okay? So glorious. You don't have to actually find any of these other numbers, right? 0 times, I'm just making a squiggle, not a W, times this vector. The vector W is actually 10. Oops. 10. Oh, no. Negative 12. There we go. Okay. So ultimately, the projection is just going to be 0. Because and when you multiply 0 times a vector, that's just the 0. Now, what you would actually write it as, your projection, and I'm sorry, I forgot. It has to be a vector. So it's going to be 0, 0. Okay? So there's that one. I'm going to make that one a little bit skinnier, a little bit smaller, I should say. Oh my goodness, I made the other stuff smaller too. Sorry. All right, and this last part D, we are just trying to find the vector Q such that it equals V minus the projection of W onto V. Okay, and that's why I did this in order, because ultimately we found things that we needed. So, it's great. We can just use things as we found them. So we knew vector V was a -6, -5. That's what we were given, right? And we are going to subtract, and we just found, I'll switch over to blue so it shows up a little better. We just found that vector over there. So it's going to be 0, 0. So ultimately, our answer is just going to be a -6, -5. Okay? And then this little part right here, and I'll switch actually to that orange. This right here, show that the dot product of Q times Q and W is 0. So all you're going to do is basically, and you don't really have to do too much because this is the same thing, but ultimately what you're going to do is, Q, W, right? You just do the dot product of Q and W. That's all you're doing. So it's basically just a repeat of our first part because it's the same vectors. So it's going to be a -6 times a 10 plus a -5 times a -12, which gives us a -60 plus a 60, which is 0. Now I think in number 4, it'll work out so it's a different vector for that part. So I'll show you again. It's just a real quick dot product. Okay, that was really long. Sorry, I was rambling. I'll try to be faster for example 4.